You're probably wondering, what is this term data type, and how does it apply to C++? When we're young, we first learn about the different types of numbers, usually with a Venn diagram like this, where we start with integers, which are our counting numbers, and then we start to add the negative numbers as well, but there's no fractional portion there. Then we move on to including fractions, which is now rational numbers, which is integers and fractions. Then we have real, such as the cube root of 5, and then we eventually learn in more advanced classes about complex numbers. Because C++ is what we call a strict data typing language, that means that the data type we choose specifies the allowable values that can be stored by our variable name. In addition to integers and rational numbers, we also need to be able to represent characters and sequences of characters, which are called strings. C++ and most other languages have special data types to represent Boolean values and data types that allow for multiple variables such as an array or a vector. Sometimes it's necessary to know the memory address or location of a variable in memory, so C++ also has pointer and reference data types. An integer is a number that can be written without a fractional component, such as -35, -5, 0, 23, 3,456. Double is the name in C++ that we attach to the data type for rational numbers. A rational number includes the fractional component, so if we want to include a number with a decimal point, we want to use double. If we don't want the decimal point, we want to use int. An example of rational numbers include -3.14, 0.0, 3.14, 1.5, 7.0. Notice the value 7 is an integer, but when you use the data type double, it automatically appends 0.0 to the end. There are 4 common fundamental data types. These include bool, which is named after the mathematician George Boole, and it represents a value that's either true or false. Remember, in machine language, we only have ones and zeros. So true is a 1, false is a 0. Next, we have char, sometimes pronounced char. This is a single character, and it's always enclosed in single quotes. So it's one character. It could also be a number in single quotes, or even a symbol in single quotes. Followed by int. Int is short for integer, and it does not include the decimal point. Double is a rational number that does include the decimal portion. In addition to those 4 fundamental data types, we have some variations, such as short, which is actually a small integer. It takes up less space. So if you know that your numbers are only going to be from 0 to 256, you might want to use short instead of int. It'll save space in memory. We have long and long, where long is new with C++ 11, but this allows us to do large calculations on large integer numbers. We have float, which is the small version of double, and that is a rational number with few levels of precision. And then the opposite would be long double, which is a rational number with extra levels of precision. We also have this ampersand. Now the ampersand is attached to a data type, such as int ampersand. And when it is, it means that the value is the address of, or a reference value. The asterisk is also attached to a data type, such as short asterisk or double asterisk, and that identifies a pointer value. C++ also has compound types. We mentioned string, and we said string is actually a sequence of characters. So it's made up of the character data type, and in order to use string, we have to have the !include string header at the top of our program. Vector and array both allow us to store multiple values within one variable name. And these data types must all have the same type. So they must either all be integers, all doubles, all characters, all strings, etc. And list is another compound data type. There are more that are not listed here, but these are the ones that we're going to use in this course. Each data type allocates a certain amount of memory to hold the values based on their fundamental data type. For example, both bool and char are allocated only 1 byte of memory. Int int is the next largest, and that has 4 bytes of memory. And double actually has 8 bytes because it needs to include that extra precision. The fundamental data types are available automatically through the standard library, but many times we also need special data types such as strings, vectors, and arrays. To use strings, we already said we need to include the header, #include string. An example of a string might be string name equals today is Monday. And since a string is an array of characters, it actually puts each letter into its own spot. Here we can see the array. All arrays and vectors are referenced using an index. The index starts at 0. So, for example, the T in today is stored at position 0. Then the O is in position 1, all the way to the Y at the end of Monday in position 14. Now notice there is an extra symbol added to the end. This is a null character, and it is used to determine the end of our string. So all strings that are stored in memory will have this symbol at the end. One thing to note is that when you do create a string literal, it cannot be changed. So since I used string name instead of doing a character array, the phrase today is Monday cannot be changed. Remember, C++ is what we call a strict data-typed language. And with C++11, it is even more important that we are careful to declare our variables with the correct data type. We have a few ways to change the data type of a value or variable. We can use what we call an implicit conversion, or we can do it explicitly. An implicit conversion happens when we have compatible data types, such as short and int. We can create a short variable and assign it to an integer variable. C++ will automatically change the data type. The same is true with a float that is stored as a double. But you must be careful to go from a smaller type to a larger type to keep data integrity. Since Boolean variables are either a 0 or a 1, we can assign a bool value to an int variable. It is also possible to save a character in an integer variable, since all characters have a numeric conversion value according to the ASCII conversion chart. Another way to change the data type is to use the static_cast command. So if we have a situation where we only want the integer portion of a double value, we can accomplish that using our static cast. Or maybe we need to save a copy of a number into a string variable. C++ has the ability to dynamically change the value of a variable or piece of data so that it can be used for a different purpose. Let's switch over to our IDE and take a look at a couple examples. Okay, I know I want to print out some values, so I'm going to automatically add my using namespace. Now in my main function, let's go ahead and declare some variables. So I'll start by declaring a double variable x, and I'm going to give it a value of 45.765. Next, I'll declare an integer y, and let's set y equal to x, but let's use our static cast so we can change the value. So I'm going to do static_cast, and what I want to do is I want to change the value of x to be an integer. So in other words, it's going to truncate the value. It's not going to round because I'm using the static cast. It'll automatically only give me the integer portion of the original number. All right, let's try this. Let's do int b equals true. Remember, Boolean variables or Boolean values, true and false, are just zeros and ones. So I can assign the value true to b and it'll print out a 1. I can also set an integer value equal to a character. The lowercase a in the ASCII conversion table is the integer value 97. So when I print it out, I'll see the value 97. All right, let's add some cout statements so we can see what's happening. So I'm going to say x:, and I'll print out x, and I'll put an endl at the end. So x is going to print out the original double value, Next, I'll print out the value after I convert it to an integer, which is y. Next, we'll print out the value a. Let's print out the value b, go in order. Remember, b is an integer, although it was given the value true. And finally, let's print out the value c. C should be the value 97. Okay, let's go ahead and run this. Oh, I have an error on line 8. I forgot, I need to put my variable in parentheses here. So let's go ahead and do that. There we go. And now we'll compile it again. And there's our results. So we have 45.765. When you make that double an integer, you get 45. When you assign a Boolean variable true to an integer variable, I get the value 1. And when I assign a character variable a to an integer variable c, I get the value 97.